So welcome back to the TX40 from World Sound. Now looking at the low TX40 manual, there are such huge differences you wouldn't think it was the same beast, but all the component numbering is different, so I can't tell you the proper procedure for setting up the VCO other than to monitor the lock detector pin. So we're going to have to do this another way, because with having a delta tune, we've already set the transmit frequency, but I've got my doubts that the receive's on frequency. I think that's quite distorted. It's 1 microvolt signal, 3 microvolt signal. I've already set the detector because I thought it sounded distorted. I'll put an S9 signal on. That is peak, but it's not how I think it should sound. So what I'm going to have to do is to revert to using a marker oscillator. So I'll just get that. Okay, well I've set up a 455 kilohertz marker oscillator on the bench, and I've put the probe around the 455 kilohertz area, and I can't hear any beat note. So what we're going to do is the crystal trimmer, which is the master oscillator crystal's just there under the wiring harness. Next to it there's the trimmer capacitor. I'm just going to adjust it to make sure we are on frequency. And we have to null that musical note. So it was on frequency. So I take all my words back. Right, we'll remove the marker oscillator from the bench. Anyway, it still sounded awful. Perhaps they do sound awful and I've forgotten how awful they sound. I have just backtracked and made sure that the transmit frequency is correct. If you remember, we had to make sure the delta tune was in the off position, and then just VR, whatever that one is, down there, for correct transmit frequency. So we should have done the receive one first, because that's on the crystal oscillator. So it was wrong to do transmit first on this particular radio, with the two being interlinked. However, it is still on frequency because that wasn't off frequency. Right, so we'll go up now with the normal tune-up, and we'll put a 1 microvolt signal on the radio. So with the cyanide meter, which is here, and the oscilloscope, which is off your screen, we're going to set up the main part of the receiver. Now, looking at the layout on this, we appear to have got these coils which are going to affect the receive. That one is part of the early stages of the transmit, so avoid that one. So we're looking at those there. Actually, there's one there as well. I would think that's part of it. And then we've got the detector, which I've already demonstrated to you down there. So what we want to do is to improve this receive. That's 1 microvolt. Slight improvement there. I'll go through those again. Because it can be interactive. I'll just try that with a bigger signal. It's quite an old-fashioned circuit. It's not got the refinements of more modern type of arrangements. We'll just see if we can touch up these IF ones. The answer is yes. I've been able to turn the attenuator down slightly. Let's go through these once again. I'll just go and put a big signal back on. Just touch that one up again. Looking for best waveform on that. And then we're going to just finish off with the detector one. That's the one in the corner there. Whilst we've got it on an S9 signal, we may as well set the S meter. Well, the S meter is the preset just there, which is vertical, and at the moment it's reading, what does that say, do you think? It's between S3 and S5, if you can see that. So we want it to be S9. There we have S9. So that was quite a lot out. This would have been very distorted on receive as it came, because the detector was well out. The coders also affects the symmetry of the received audio, whatever there is in the circuit, was also out, and we've been able to gain a bit of sensitivity there. So let's see what it's doing now. It's 3 microvolts, 1 microvolt, 0.3 microvolts. Yeah, there's still a bit there, isn't there? Of course, when you set these type of things, you always need to make sure your RF gain is to full. You can hear that working all right. Okay, so the next thing we need to do is to set the squelch. So I've turned the signal generator off, advanced the squelch on the radio to threshold, turn the signal generator up, that came in at 10 microvolts, that's no good to us. We want it much more sensitive than that. Looking a bit further, I see we do have another squelch preset, this time on the board. We've got a vertical preset just there. So I'll just advance that. Oh, it's a bit dirty. See whether that's any better. Switch the signal generator back on. Now that comes in at 1 microvolt, that's much better. Now switch that to full. Now that's too weak now. back that off a fraction. Coming in at between 1 and 3 microvolts. Now we'll turn the squelch up to full. Comes in at 10 microvolts. Threshold. Signal drains are on. 3 microvolts. Squelch to full. 100 microvolts. That's it. We've got it cracked. So I've manipulated this kind of coarse adjustment on the back of the control. I don't know whether it's supposed to be there or whether it's been added. And what's clearly supposed to be the squelch sensitivity there. So that's working ideally. It's coming in at between 1 and 3 microvolts. And at the squelch control's maximum, it's a 300 microvolt signal. So we're looking at not a lot over S9 to bring that in. So there we are. That's set up the squelch control. And that was quite finicky. So as far as I can see, that concludes everything we can do to the World Sound PT40.